1, I have log W1. So this is going to be a very simple one. So I have a log 1 to the base of W, and we have seen this before. I repeated that many times. So the fact that when we have log of 1, so no matter what is going to be the base, it is always going to be 0. So simply put 0 right there. Okay, and the last one. So let's see the last one. What do we have? I have log 5 1 over 625. So it's going to be log 5. I have 625. Okay, so I'm going to use the same ideas that I've seen previously. The fact that first I'm going to relate between the number 5 and the number 625, and of course there's a relationship between them. So 625 is actually 5 raised to the power of 4. 5 to the power of 2, it's 25. 5 to the power of 3, it's 125. And 5 to the power of 4, it's going to be 625. And using the same idea that we have seen before, I'm going to write this as 4 log of 5 base 5. And this whole thing will become 1. So this is going to equal 4. So that is going to be for question number 1. Okay, now I'm going to start with the second example, so which is question number 2. So let's see what this question wants. The question number 2, so what we are expected to do is we're going to simplify each expression, so using the law of logarithm. You know what? Let me copy this so I don't have to keep looking up for this. Take a screenshot, copy, and let's paste it here so we can refer to them later. No, I have another idea, because I don't want to keep going up and down, because I am afraid that you will get dizzy by watching me scrolling up and down the slide. So let me do this instead. Okay, so that's our question number 2. Okay, so for question number 2, so it actually asks you to simplify each expression. So when you say it simplify, what does it mean by simplify? So meaning that instead of like having 1, 2, 3 logarithms separately, so what you have to do is you have to put them together. Instead of having 3 log, there will be only 1 log. So that is expected from simplifying operation. Okay, first of all, let me give you tips before you start. Simplifying them. So step number 1 is get rid of the constant at the front. Get rid of constant at the front. So what do I mean by constant at the front? What am I referring to? I'm referring to this thing over here. So I have a 3 in front of the log x, and I have 2 in front of the log for x. And how am I supposed to get rid of that? So I'm going to use a very simple rule that this can be moved and become the power of the function that I have. But be very careful over here. So when I move the powers, it's going to become log of x squared. And this one is going to be 3 log of x and minus, right? So I want you to be careful for this. So these two are actually together. So whatever that goes after the log, they are actually together. There's supposed to be a bracket written. So that is why when I put this as a power, this is going to be log of 4x raised to the power of 2. So the power of 2 does not only go for x, it doesn't become like this. It doesn't become log of 4x to the power of 2 like this. No, this is wrong. But actually both of them are being raised to the power of 2, because these two, they are together. What goes after the log, there's a bracket around. So this is actually a bracket around, and this two as well. Okay, but it's not written. It's usually not written, because like when you have a look at that, you should know already. So that 4 and x, they are together. Okay, now that, sorry, I should have x3 over here. So that is what I wanted to do. I wanted to get rid of the constant at the front. So that is why. Okay, so now what happened is that I get rid of the constant. I don't really get rid, but now like all the coefficient here is being 1. This is 1 log of x squared, 1 log of x cubed, minus 1 of log for x squared. So that is what I wanted. So everything has become 1 multiplied by the log now. So now that you have get rid of the constant at the front, then only you can start using the property. So now instead of having 1, 2, 3 log, I'm going to put them together according to the law that we have seen before. So I'm going to put this as a log. Okay, so according to the law that we have seen before, so if I have, okay, step number 2, so start using law. So according to what we have seen before, so if I have a log of a xy, so this is going to equal log of ax plus log of ay. So now what I'm going to do is I'm going to reverse it. I have it in this form, so I'm going to make it into product. So basically, if you have two functions, which is both a plus, when you put them together, so it's going to be product. And when you have log of a x over y, and this is going to equal log ax minus log ay. So whatever that goes on the top, I'm referring to this one, so whatever that goes on the top, it's going to become positive, and whatever that goes off the bottom, so this is going to be the over part. It's going to become the division, it's going to be at the bottom. So that is why, so let's make the rule over here. So whatever that has a positive sign, this is actually positive sign, so it's going to go on top of your log, and whatever with a negative sign is going to be at the bottom. So it's actually raining outside. You will be hearing the rain in this video. I'm really sorry for that. I'm not expecting that it's going to rain. So therefore what this well, for this case, what happened is that, so this two term, they are positive, so it's going to go on top. So I'm going to have x squared multiplied by x cubed, and this is minus, so it's going to be at the bottom. So I'm going to have 4x squared, which I can actually write as 16x to the power of 2. And of course, we can simplify this. So I can write this as log. So these two are going to cancel each other. So let me use a different color for that so we can see that clearly. And therefore, so this is going to simplify to x to the power of 3 over 16. So that is going to be our simplest form of log x squared plus 3 log x minus 2 log of 4x. So that is going to be for A. So let's proceed to B. So I'm going to copy that. No. Okay, now let's have a look at B. Alright, for the case of B, so I'm going to use the same idea. So first of all, before I start, I'm going to get rid of the constant at the front. So this 2, and I have a half right there as well. So therefore, what happened to my function is that, so this is going to be log of x to the power of 2 plus log of y to the power of 2. So minus log of z to the power of a half. It doesn't matter if it's fraction. So it's still going to be the same idea. And now that it is in this form, then only I can apply the log property. So remember, whatever that is positive, which is referring to this 2, so it's going to go on top, and the negative is going to become division and become the fraction, the denominator of the fraction. So here I'm going to first collect all the positives 1. So I'm going to have x squared multiplied by y squared, so plus become product. And at the bottom, I'm going to have z to the power of 1 over 2. Or I can actually write that as square root of z. That is the same, because square root of z is actually z to the power of a half. Okay, so that is going to be the simplest form that it could be. So now let's proceed to C and D. Finish this off. Okay, so let's start with C. So C will be the same idea as well. So what happened is that first I'm going to get rid of the 2. Okay, and for this one, what's going to be different about this is that I have a 3. So let me see what we can do about this. Okay, that's one thing that I forgot to remind you about the law of the formula, about the logarithm law over here. So you can only apply the logarithm law when all of them have exactly the same base. Okay, so if you notice what happened over here is that all of them have the same base, then only we can do the operation. So here log a, then only we can put them together as being the product, and this is a and a, it become x over y. The positive become the top, the negative become the bottom. Okay, and so the main point is that you can only do the operation when the base are the same. And even whatever that I did before, so for question A and B, they all have the same base. So here the base is not written, so that simply means that it has a base of 10. So all three have the base of 10. And same goes for number B. So we have all ln, which is log to the base of e. Alright, so what happened for this case is that, so I have two logarithm functions, so both to the base of 5, but I also have a constant 3 over here, so which is not in term of logarithm. So how do we cater with some like that? So let me show you in this example. Right, so here I'm going to write this as log x to the base of 5, and here of course I'm going to bring up and to become the power, so I'm going to have a log of 5x and plus, so here is going to be 3. Okay, but however, like remember I always told you that whenever you have a function, you can change it any way you like as long as the value doesn't change. For example, if I have a 5, so instead of writing the as 5, I can actually write this as 3 plus 2 because that's still 5. Or I can also write that as 4 plus 1 because that is still going to be a 5. Or I can write this as a 5 over 1 because that is still a 5. So remember, you can change your function, your number, any way you like, but the value has to remain. If it's supposed to be 5, at the end of the calculation, it is still supposed to be 5. Alright, so therefore what I'm going to do is, instead of 3, so I want this to be 3 multiplied by 1 because we know that 3 multiplied by 1, that is still going to be 3. So let me modify this and make it in terms of log 5 as well. So therefore I'm going to write this as log 5x minus log 5x to the power of 2. Sorry, I missed out the power. I should have x to the power of 2 for the middle term. And this one, I'm going to write this as 3 log of 5. Remember, so when you have a constant that goes after and the base, they're the same, automatically that is going to be 1. And remember, I still don't change the value, it's still going to be the same because log 5 is still going to be 1. But what happened is that I just want to make sure that all the term has the same base, which is going to equal 5. So therefore what happened next is that, so the last term, I'm going to bring up the power. So this is going to be log base 5. So 5 to the power of 3. So now that it's in this form, then only I'm going to make it into the simplest form. So I'm going to have log base of 5. Remember, the positive goes on top, which is going to be x for this case. And also 5 to the power of 3. So there's a minus over here. So it should be at the bottom. So which is going to be x squared. And of course, I can further simplify this because this is going to cancel. And I'm going to end up with a log of 5 to the power of 3 over x. So that is going to be the simplest form that it could be. So that will be C. And the last one is going to be D. So let's have a look at D. So I know that some of you are super well versed with this already. And of course, if you know this already, so don't bother watching the video, just proceed right away to the exercise. Okay, this will be my D. Okay, for D, I'm going to use the same trick as what I have done previously. So just going to be another example. So here, I'm going to bring this up. I'm going to write that this is going to equal log of 5 to the power of -2. So you bring all of them up here. So it becomes 5 to the power of -2. And of course, like if I want to put them together, I have to make this as a log as well. And it must have the same base, then only I can do the operation. So therefore, I'm going to write this as 2 log of 4 with a base of 4. Then only it will become 2 multiplied by 1, which is still going to be 1. And this is going to be log 5 to the power of -2. and plus log of 4 to the power of 2. Okay, so what I'm going to do next is I'm going to simplify them. So I'm going to write this as log 4. So this is a plus and this is a plus as well. So therefore I'm going to multiply both of them. So I'm going to have 5 to the power of -2 multiplied by 4 square. So that is going to be my function, and of course you can find them. So 4 square is going to be 16. You can actually write that this is going to equal log of 4. So this is going to equal 4 square over 25. So that is going to equal log 4 16 over 25. Okay, so or another way that you can actually do, so or let me put over here, or so you can simply leave the negative. Okay, so if you leave out the negative, what happens is going to become like this. So I'm going to have negative, so log of 4 5 to the power of 2, and then I'm going to have plus log 4 to the power of 2, and then when I put them together, log of 4, so this is positive, so it should be on top, so I'll end up with 4 to the power of 2, and this is minus, so it should be at the bottom, so this is going to be 25. So you get the same answer as previously. So whatever that you decide to do, whatever that you decide on, okay, so both of them are going to give you exactly the same answer.